Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. Today we will continue our topic in reversible and irreversible process. So what is reversible process? Reversible process is a process that can reverse without leaving any trace on the surrounding. If you can see this diagram, this is piston cylinder devices, and we can see that the piston is moving from this position up until this position. After some times, the piston is moving down back to the original position. Along the way, there will be no heat loss. Okay, so since there will be no heat loss, therefore we can say that this process is ideal process, which never occurs. Next, we go to irreversible process. Irreversible process is contrary from reversible process. And if we can see from this diagram, the piston is moving from this position to this position, and after sometimes it does not go back to its original position because there will be heat loss along the way. So we can say irreversible process are result of straying away from the curve, therefore decreasing the amount of overall work done. So, for the conclusion, we can conclude that reversible process is ideal process and irreversible process is actual process. So this is the differences between reversible process and irreversible process. Next, we go to the Carnot cycle and principle. And this Carnot cycle, I present it with these devices. In this diagram, we have pump, we have boiler, we have turbine, and we have condenser. And compressor and turbine we already cover in SFEE devices topic. And we know that the function of the pump or compressor is to increase pressure. Okay, so the pressure will increase as well as temperature, and the high temperature and pressure will enter the boiler. At the boiler, there will be heat addition. Okay, so the heat will heat up the steam or liquid, and at state 2, the temperature is at the highest temperature. So we can say at T2, the phase of the liquid or steam is in superheated. So the superheated steam will enter the turbine, and we understand that the function of the turbine is to decrease the pressure, and at the turbine we have W dot out, work output, and at the compressor we have work input. Okay, so since the pressure and temperature is decreasing, so it's still in steam, and we convert the steam to the liquid steam phase through condenser at isothermal process. Okay, this cycle we call it as a reversible process. Process 1, 2, this is occurs at boiler, and this is isothermal heat addition. Process 2 to 3 occurs at turbine, and this is adiabatic expansion. Okay, and process 3 to 4 is isothermal heat rejection at the condenser, and 4 to 1 is adiabatic compression at the compressor. W dot in. Okay, Carnot cycle has a drawback. Okay, because in adiabatic process, which is occurs at 4:1 and 2 to 3, which is occurs at turbine and compressor and turbine. Okay, the process must be carried out faster because it is not available for heat transfer. Okay, and for isothermal process, which is in 1 2 and 3 4, it must be carried out in slow manner. These two combination, which is adiabatic and isothermal in cycle, is impossible, which is not practical actually. Alright, so we can say that Carnot cycle is just a theoretical cycle and used for comparison with other cycle that we will learn in chapter 4 and chapter 5. Okay. Uh, so Carnot theorem, all engine working between the same temperature limit and the efficiency of reversible engine is greater than the efficiency of irreversible engine. New reversible or ideal is greater than efficiency of irreversible or actual efficiency. Alright. So, what is Carnot efficiency? Carnot efficiency is the differences of high temperature minus low temperature over high temperature. That's all for reversible, irreversible process and Carnot cycle. Thank you.